Good morning, dear students. Welcome you all to the next academic year. In this very first video, you are going to learn about the basic concept of rational numbers.
All of us know what a number line is. And the numbers we see here on the number line are called integers. On the right side of 0, we have positive integers, and on its left, we have negative integers. Integers we are familiar with, but what about numbers like these? 1 by 3, 5 by 6, or minus 7 by 12. Each of these are numbers, but we don't use them as often as we use counting numbers. Such numbers are called rational numbers. But we need to define them well. We cannot say numbers like these are rational numbers. We say that they are of the form p by q. One number in the numerator and one in the denominator. But there are a few conditions we need to know. P and Q should be integers. We can have only integers in place of P and Q. And there is another important condition. Q should not be equal to 0. Why do we have the second condition? Say I ask you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what will give you 3? There is no such number. This value is undefined. So this is the basic definition of rational numbers. It is a number of the form p by q, where p and q are integers and q is not equal to 0. There are many questions that should pop up in your head when you see this definition. What is the difference between rational numbers and fractions? Are integers classified as rational numbers? What about 0? How do we plot such numbers on a number line? And how do we compare two rational numbers? For example, if you are asked to compare 1 and 5, you could easily say that 5 is greater of the 2. But what if you are asked to compare numbers like 6 by 7 and 13 by 15? How will we find out which one is greater? How do we represent rational numbers on a number line? A number line looks something like this. The positive integers are represented towards the right of 0, and the negative integers are represented to the left of 0. The numbers increase when we move towards the right and decrease when we move towards the left. It's easy to plot integers, but how do we plot numbers like 3 by 4? Before we understand how to plot this, we need to understand a very crucial point. Every integer except 0 has a corresponding integer. The integer 1 has minus 1 as its corresponding integer. The integer 2 has minus 2 as its corresponding integer. Similarly, every negative integer will have a corresponding positive integer. This tells us that if we somehow manage to plot 3 by 4, we can mark a point at the same distance on the left-hand side of 0, which is minus 3 by 4. Now we can move on to the representation of rational numbers on a number line. To simplify things, we can classify the examples into two types. Ones in which the numerator is less than the denominator, and the other in which the numerator is greater than the denominator. Note that we see only the numerical value to compare the numerator and the denominator. For example, if we are plotting minus 9 by 5, we compare 9 and 5 and not minus 9 and 5. So minus 9 by 5 will come in the numerator greater than denominator category. We will look at two examples in the first category in the next video. One of the categories of plotting the rational numbers on the number line is when the numerators are less than the denominators. Let's try to plot 1 by 2 and minus 1 by 2 on the number line. First, we see how we can plot 1 by 2. The numerator 1 is less than the denominator 2. When the numerator is less than the denominator, the positive rational number will be between 0 and 1. So we draw the number line like this. The number 1 by 2 has to lie somewhere between 0 and 1. Now we divide the length between 0 and 1 into equal parts. How many equal parts is the question? The denominator tells us the number of equal parts. The denominator is 2, so we divide it into two equal parts. This line divides this region into two equal parts. But what does the numerator tell us? It tells us the number of parts starting from 0. The numerator is 1, and therefore we take one part from 0 and mark 1 by 2 here. We can use the same procedure to mark minus 1 by 2 on the left side of 0. Divide it into two parts and mark minus 1 by 2, one part away from 0. Just as integers had corresponding values, rational numbers too have corresponding values. In our example, minus 1 by 2 corresponds to 1 by 2. Let us look at another example where the numerator is less than the denominator. We have to plot 3 by 4 and minus 3 by 4. Let us plot 3 by 4 first. Since the numerator is less than the denominator, we know that the number will be between 0 and 1. So we draw the number line like this, with just 0 and 1 plotted. Remember, the denominator tells us the number of equal parts. Since the denominator is 4, we divide the length between 0 and 1 into 4 equal parts. Drawing these three lines gives us 4 equal parts. Now we move to the numerator. The numerator tells us the number of parts from the number 0. Since the numerator is 3, we move 3 equal parts from 0. 1, 2 and 3. So we mark 3 by 4 here. Now let us plot minus 3 by 4. Since 3 is less than 4 and the rational number is negative, we know that it will come between 0 and minus 1. We divide this length into 4 equal parts as the denominator is 4. And we mark minus 3 by 4 3 parts away from 0. That's it. We have plotted the points. But let me ask you a question. You have plotted the numbers 3 by 4 and minus 3 by 4. But do you know which numbers are plotted on these points? Here's your answer. Since this is one part, we mark 1 by 4 here. Since these are two parts, we mark 2 by 4 here. Similarly, we can plot minus 1 by 4 and minus 2 by 4 here. This was just for your understanding, and you don't need to mark all the points if you're asked to mark just 3 by 4 and minus 3 by 4. In the next video, we will look at an example in which the numerator is greater than the denominator. In this video, we will try to plot rational numbers whose numerators are greater than their denominators. Let us plot 7 by 4 and minus 7 by 4. We try to plot 7 by 4 first. The first step in such kind of problems where the numerator is greater than the denominator is to convert it into a mixed fraction form. You would have learned this in your earlier classes, but let me quickly show you how. We only have to divide 7 by 4. We get the quotient as 1 and the remainder as 3. So we write the mixed fraction as quotient, remainder by divisor. This is the whole part and this is the fractional part. So we can write 7 by 4 as 1, 3 by 4. 1 is called the whole number part and 3 by 4 is called the proper fraction part. Each of the three numbers, 1, 3 and 4, tell us something about where 7 by 4 is plotted on the number line. The whole number part tells us the position of 7 by 4. So 1 tells us that the rational number 7 by 4 is between itself and the next whole number. The next whole number is 2. So we know that 7 by 4 is between 1 and 2. So we draw the number line accordingly with just 0, 1 and 2 marked. The denominator of the proper fraction part tells us the number of equal parts this segment is divided into. Since it is 4, we divide this segment into 4 parts. This segment between 1 and 2 is divided into 4 equal parts. The numerator of the proper fraction tells us the number of parts from the first whole number. So it is 3 parts away from 1. So we mark 7 by 4 here. What about minus 7 by 4? We can write minus 7 by 4 as minus 1, 3 by 4. Now the number minus 1 tells us that minus 7 by 4 is between itself and the next number. Make note of the fact that the next number will be on the left hand side since minus 7 by 4 is a negative rational number. So the next number is minus 2. Now we can say that minus 7 by 4 is between minus 1 and minus 2. The denominator tells us the number of equal parts this length is divided into. So we divide it into 4 equal parts by marking 3 lines. The number 3 tells us the number of parts from the number minus 1. So leaving 3 parts from minus 1, we mark minus 7 by 4 here. With that, we are done with the topic of plotting positive and negative rational numbers. Now we know that square root of 2 is an irrational number. If you use a calculator to calculate the value of root 2, you will get something like 1.4142135 and so on. This value that you get is actually non-terminating. It is never-ending. Also, you will not find any pattern in the digits after the decimal. Hence, it's also called a non-recurring decimal. There is no pattern that occurs again and again. These kinds of numbers are called irrational numbers. Consider square root of 3 for instance. You will get its value as 1.732050 and so on. Even this decimal is non-terminating and non-recurring. So root 3 is also an irrational number. You can try calculating the values of root 5, root 6, root 7 or root 8. You will find that all of them result in non-terminating, non-recurring decimals. But wait, root 9 equals 3. This is a rational number. Yes, root 9 is not an irrational number. In fact, square root of any perfect square will be a rational number. But the square root of any number which is not a perfect square will always result in an irrational number. Here's the interesting part. If you know these 2 points well, you can even form an irrational number by yourself. Let's see how. We have to form a number which does not end and does not repeat any pattern. Something like 2.01001, 0001, 00001 and so on. Here, the number does not end and is also non-recurring. This means that there is no pattern that repeats forever. You can even have a number like 15.2349, 449, 4449, 44449 and so on. This is also irrational as it is non-terminating and non-recurring. Where does this concept help us? Say you're asked to find 2 irrational numbers between 1.23 and 1.25. Remember, 1.24 is incorrect as it's terminating. We need a non-terminating, non-recurring decimal. Yes, but we know that 1.24 is between these 2 numbers. After 1.24, we can start writing 01, 001, 0001 and so on. That's one irrational number between these 2 numbers. Again, let's write 1.24 and this time we write 02, 002, 0002 and so on after it. That's your second irrational number. So to find irrational numbers between 2 numbers, just write a rational number between them and then add non-terminating, non-recurring digits after it.
So, my dear students, rational number is of the form p by q, where p and q are integers. Q is not equal to 0. Hope you all understood about the basic concept of rational number. In the next video, you are going to learn about the mathematical trick in dividing the numbers. So, it will be very useful for you. Watch the video clearly.
Now, we would be learning the easy calc tricks to divide the numbers really fast. Okay, so my question to you is, again, very straightforward. How fast can you divide this huge number with 43? Okay, since this number has how many digits? 1, 2, 3, 4, 5, 6, 7. Okay, since it's a 7-digit number, so I'm giving you 12 seconds to do it. And your time starts now. Give it a try. your time is up. The correct answer is 62,314. Now you don't have to tell me that you did not get that answer, or for that matter any answer at all, for I know that unless you use a calculator or you know this easy cal trick of dividing numbers, there is no way by which you can divide a 7-digit number in 12 seconds. So let's first check out the usual way of doing it, then I'll show you the faster way. Now, before we see the usual way to divide these numbers, let me warn you, as you know, that the usual way to divide any number is very long. So, please be patient. Alright? So, let's start now. You might be aware that this entire number that is being divided is known as dividend. And this number that is dividing this number is known as divisor. Okay, and we are going to write our answer here in this space, and that answer is known as, in technical terms, quotient. Okay, and if there is any digit left in the end, that would be the remainder. So now let's start dividing these numbers. So break this dividend into manageable parts. So first we are going to divide 267 by 43. Okay, but that again is a very difficult thing to say. If I ask you how many times 43 will go into 267, the answer would be difficult to say right away. So what we'll do, we are going to make it more manageable. So forget about this 3 and forget about this 7. Now just tell me how many times 4 will go into 26. So 6 times is 24. So write that 6 here as your answer digit or quotient, and then multiply your digits of divisor with this answer digit. So 6 3 times is 18, and 6 4 times is 24, and 24 plus 1 is 25. Now subtract these digits. So 17 minus 8 would be, we have borrowed 1 from here, so this becomes 5 and this becomes 17. So 17 minus 8 is 9. Now drop the next digit down. So copy 9 here. Okay. Now once again the same story. 43 will go in 99 how many times? So either you can straight away say 2 times, or you can once again hide this number, this digit and this digit here. So 4 2 times goes into 9. So I'll put 2 there. Now once again multiply this answer digit with the digits of the divisor. So 2 3 times is 6 and 2 4 times is 8. Now once again 9 minus 6 is 3 and this is 9 minus 8 is 1. Now drop down the next digit, it is 5. Now the same process again. Hide this 3, hide this 5 and ask yourself how many times 4 will go into 13. Okay, so 4 3 times is 12. So write that 3 here and once again multiply this with the divisor digits. So 3 3 times is 9 and 3 4 times is 12. Now 9 cannot be subtracted from 5, so borrow 1 from here, so this will become 2 and this will become 15. 15 minus 9 is how much? 6, and this is 12, minus 12 is nothing, 0. Now drop this 0 down, so this becomes 60, and once again the same thing. 4 how many times will go in 6? 1 time, so put 1 here, and 1 3 times is 3, and 1 4 times is 4. Now I had this fear always that we are going to run out of space, and now we have actually. This method is indeed very long, no problem. So 10 minus 3 is 7 and this had become 5, so this is 1. Now drop down this 2. Thankfully this is the last digit. This is 2 here. Now 4 will go how many times in 17? So 4 times is 16. So I write 4 here and once again I multiply this So 4 3 times is 12. So where should I write 12? Okay, I'm writing it here. And 4 4s are 16, and 16 plus 1 is 17. So subtracting 172 from 172, the remainder would be nothing, 0. Okay, so finally our answer or our quotient is this, 62,314. Now I know that you would be delighted to see the faster way of dividing the numbers, because in faster way you'll get the answer in maximum 1 or 2 lines. Okay, now to divide these numbers the faster way, all you need to do is break this divisor into two manageable numbers. I'll break it as 4 and 3, where 4 would be our main divisor. Okay, and this 3 would be called an unused digit. As the name suggests, we are not going to use it much to divide. Now the logic is that dividing with 43 might be difficult, but dividing with 4 is not, isn't it? So we'll be dividing with 4 all the time. Let's see how we go about it. Now 4 how many times will be 26? So 4 6 times is 24. So write 6 here. This is our answer digit. And what is the remainder? 26 minus 24 is 2. So write that remainder digit here. Are you getting the point? Now read this as 27. This would be read as 27. So our next dividend would be 27 minus the product of this unused digit and the answer digit that we have put. Okay, so 27 minus 3 times 6, that is 18. So 27 minus 18 would be 27 minus 8 is 19, and jumping down 10 is 9. So now our dividend is 9. Okay, 4 how many times goes in 9? 4 2 times is 8. So write 2 here, and the remainder is 1, isn't it? 9 minus 8 is 1. So I write 1 here. Okay, now this is read as 19. So our next dividend would be 19 minus the product of this unused digit and the answer digit that we have last put. Okay, so 19 minus 3 2 times is 6. So 19 minus 6 is 13. So this is our next dividend. So 4 goes how many times in 13? 4 3 times is 12. Again the remainder is 1. So the next dividend would be 15 minus 3 times 3. That is 9. 15 minus 9 is 6. So write 6 here. Now 4 goes how many times in 6? 1 times. As simple as that. And the remainder is 2. So write that 2 here. So now this is 20. The next dividend would be 20 minus the product of this unused digit and the answer digit that you have last put. So 20 minus 3 is 17. So 4 goes how many times in 17? 4 times is 16. So I write 4 here, and remainder is 1, isn't it? 17 minus 16 is 1, so I write 1 here. Now the next dividend would be 12 minus 3 times 4, that is 12. That is 0. Moment you get 0 as the dividend, that means the answer that you have got so far is the complete answer. So this is my answer, 62,314.
In the next video, you are going to learn about the 3 by 3 magic square puzzle. Watch the video clearly and you too solve this puzzle. Students, hope you had fun with the puzzles. Watch the next video and learn how to do multiplication using your fingers.
Now, imagine that your fingers represent the numbers 1 through 10. Your left thumb is the number 1 and your right thumb is the number 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, let's begin. Let's take an example. Say 9 times 7. Let's start by folding the 7th finger down like this. You're seeing the answer right now, actually. There are 6 fingers to the left of the folded finger 7, and there are 3 fingers to the right of the folded finger. So the answer is 63. You're seeing it right now. It's a super nice trick, right? Now, let's do the 9 times table from the very beginning. 9 times 1 is 0, 9. 9. 9 times 2 is 1, 8. 18. 9 times 3 is 2, 7. 27. 9 times 4 is 3, 6. 36. 9 times 5 is 4, 5. 45. 9 times 6 is 5, 4. 54. 9 times 7 is 6, 3. 63. 9 times 8 is 7, 2. 72. 9 times 9 is 8, 1. 81. And finally, 9 times 10 is 9, 0, 9.
Students, hope you enjoyed. Watch the next video and learn how to do the fraction bird by using the color papers.
Next project using the fraction. It is a fraction bird. Let's see how to do it.